So you're looking at this sheet that says real world examples of scientific notation. So scientific notation gives you a shortcut, okay, of writing really long numbers. So let's find the longest number on this sheet. Let's put it to use then. So if you look at number 10, okay, the mass of an electron it's really small, right? It's this long decimal number, less than 1, okay, kilograms. Alright, so instead of having to read this number or write it, we're going to rewrite it in scientific notation. So the first thing we need to do is make this number make the coefficient a number between 1 and 10. So where would I put my decimal? Well, all of these are zeros, so I'm going to put my decimal right in here between the 9 and the 1. Okay, I'm going to round this. I'm not going to actually I'm going to round this to 1 decimal place. Okay, instead of writing 9.10938822 on this sheet, go ahead and just round stuff to 1 decimal. Okay, since this is a shortcut. Now you can't do that on iExcel. On iExcel, you'd have to write 9.10938822. Okay, but here we're just going to round to 1 decimal. 9.1. Okay, so I have 9.1 as my coefficient times 10. Alright, so now I need an exponent. Okay, so all this is just a part of scientific notation. I just need the exponent. This number is less than 1, so I know it's going to be a negative. Okay, and let's count how many places I would have to move the decimal. Okay, I pre-counted. That's 30 zeros, so I have to move it past these 30 zeros and then also past the 9. Okay, so I had to move it 31 spaces. So this number in scientific notation would be 9.1 times 10 to the negative 31. Okay. Alright, let's take a look at number 5, another really long number. It's the distance that light travels in 1 year. Alright, so I need, first of all, I know my exponent is going to be positive. This number is really big. It's bigger than 1. Okay, so let's figure out the coefficient. I need a number between 1 and 10 for the coefficient. Where would I put my decimal? I would put my decimal right there between the 9 and the 4. Okay. Alright, I could round this to 9.5, but just to not confuse anyone, I'm just going to keep it at 9.4. Okay, so 9.4 times 10. Now I need this exponent. Okay, it's going to be positive because this number is bigger than 1. So it starts at the end here, and I want to move it to the 9 between the 9 and the 4. Okay. Alright, so I move it past these 3 zeros, these 3 zeros, so that's 6. Okay, these 3 numbers, so that's 9, that's 12, that's 15. So counting by 3s, 3, 6, 9, 12, 15. I had to move it past 15 numbers. So 9.4 times 10 to the 6th. Okay, and if you want to be more accurate, okay, maybe I should have done that, but it would be 9.5 because this number to the right of the 4, it's bigger than 5, so I'd have to round up. Okay, so 9.5 times 10 to the 6th, but here I just keep it 9 times 4 times 10 to the 6th. And let me not forget the units also, kilometers. Okay, same thing with number 10 down here. The units are just kilograms. Okay, and then the last one I'll do with you is number 6. Alright, so same thing. I need a coefficient that's between 1 and 10. Where am I going to put my decimal? I'm going to put it between the 1 and the 3. Okay, that gives me a 1.3. 3 times 10. This number is less than 1, so I know I'm going to have a negative exponent. And it looks like here I would have to move the decimal 1, 2, 3 spaces. So 1.3 times 10 to the negative 3, and the units are grams per cc, cubic centimeters. Okay.